Greetings and welcome to the Introduction to Astronomy. In this week's Misconception in Astronomy, we are going to talk about light, and is light affected by the force of gravity? So let's go ahead and get started here, and what we can say is light affected by gravity? Yes, it is. And we know that specifically under Einstein's general theory of relativity, which will say that light is bent when passing near a massive object. So we can see an image kind of demonstrating that here. We see two paths for the starlight and two different positions for the star. The actual star's position then has to travel through, in this case, near a black hole, and the black hole deforms the space and time around it, forcing the light to travel a different path. Now you may wonder why the light doesn't travel straight over that dip, and we have to remember that this is really a two-dimensional representation of three-dimensional space. So in order to stay within space, you have to stay on that surface, otherwise you are leaving space and time altogether. So it cannot travel there. It would be like drawing a line on a piece of paper that might be bent. In order to go from one point to another, you have to stay on that piece of paper, not jump through the empty space between. That paper would be our space, and that's the same here. It is our surface that we must stay on and follow the shortest path within that bent space. And then we can see the path straight back, which is where we would observe the star. But under Newtonian gravity, it's a little bit more difficult to say exactly what would happen to light. So under general relativity, what happens? Well, general relativity describes gravity as a bending of space and time. So any object with mass would bend the space-time around it. So the Earth would do this, and that keeps the moon in orbit. The moon would do this, the sun would do this, and that bends space. The larger the mass, the more the bending is. So we see in our image a black hole would severely distort space and time around it. A very low mass object would not distort it as much. But all objects, including light, follow this curved path then. So yes, their paths are affected by gravity. Now, what are some observations of this? How do we know that this actually occurs? I can show you a diagram here, but what do we actually see that tells us this occurs? And we can take a look here at some examples, one being an eclipse. And this is an example of an eclipse from 1919, where Arthur Eddington and Frank Dyson actually went to an eclipse to observe specifically the positioning of stars, and then to take pictures of those same stars here near the sun, and take them 6 months later or earlier and compare the positioning to see whether it was what would be calculated under Newtonian gravity or under general relativity, and general relativity was found to be correct. The prediction it made was correct. Now, we also see this in gravitational lensing. So here we see an example of that where there are multiple images of a distant galaxy present as the light passes through the gravitational field of the galaxy cluster. And if you can get everything lined up just right, you can get this in a perfect circle. And here we have one that's very close to that, where you can have one object lined up almost directly behind another, giving us what is called an Einstein ring, or ring of a material that's all the same very distant galaxy that is directly behind this other galaxy, and we see all those other images of it put together there due to that light passing through the gravitational field of the nearer galaxy. So let's go ahead and finish up here with our summary. And what we've looked at today is that gravity does affect the path of light. It bends the light and causes its path to change. We see it under general relativity, and we can also see a prediction of this under Newtonian gravity, but by different amounts, and general relativity is what matches with what we see. And another way we see this is through gravitational lensing, is another prominent way that we see the bending of light by gravity. So that concludes this week's misconception on astronomy on light being unaffected by the gravitational force. We'll be back again next week for another misconception in astronomy. So until then, have a great day, everyone, and I will see you in class.